So this question compared to, other questions you would usually get in this section, it's not very difficult because it's basically a substitution. Once you know your identities, all you have to do is substitute the value that they gave you to find what you need. So this one was relatively straightforward. They gave you this. They said tan of theta. Okay, that's theta minus alpha is equal to a half. They also told you that tan theta is equal to 3. What they want you to find is the value for alpha, the acute angle alpha. They did not specify how. They did not specify whether they want it in degrees or in radians. So I would suggest to you just put both of them, just in case. But they didn't specify. So technically, if you put it in radians, then that would be correct. If you put it in degrees, that would also be correct, right? Because they didn't specify whether they want radians or degrees. Hold on, right? People are joining. So tan theta minus alpha. This form right here should look familiar to you. Why? Because we have a double angle formula that looks similar to that. Tan of A minus B. When we were doing this, can anybody tell me what would I put here? What is this identity? Tan A minus B.
Miss, I think it's tan A minus tan B all over 1 plus tan A plus tan B. Tan A
Careful.
divided by tan B?
No.
Times, I think. One of them.
Oh, well, you need to know. Tan A times is multiplied, right? That's the identity. The tan A minus B. So you apply the same thing here. Just in this case, instead of putting A and B, you put theta and alpha. So let me just I wouldn't put A and B because they gave me the angles theta and alpha, right? So I put it in yellow as well. Theta, alpha, theta, alpha, theta, alpha. They want you to find the value of alpha, and they told you alpha is an acute angle. They gave you that tan theta is equal to 3. All you have to do now, substitute this value into A, and you could find whatever, right? Because they told you that this is equal to a half. So let me just put the equal to a half right here. All I'm doing now is a substitution. And then tan theta is 3. So therefore, looking at this, it's 3 minus tan alpha over 1 plus tan theta is 3. They told me that. So that's 3 tan alpha is equal to a half. You want to find alpha, so all you do now, basic algebra, you transpose to find alpha. That's all you have to do. That's all you have to do for this question. So let me just point out one thing real quick, because I know this is a common mistake. You see, some people might be tempted to say, oh, tan alpha, I could cancel these. No, that's not how it works. You see this? You see how it's 3 minus tan alpha and 1 plus 3 tan theta? These cannot cancel, right? But if it was like minus tan alpha divided by 3 tan alpha, then you would have been able to cancel them out. But you see, since there's sums on differences here, no, cannot cancel them, right? That's the common mistake. So please don't make that mistake. Can't cancel them. Cannot. Can't. Right. So all we're doing is transposing now. So if I cross multiply, I'll get 1 plus 3 tan alpha is equal to 2 by 3 minus tan alpha, right? So that'll give me 6 minus 3 tan alpha. And like I said, I'm trying to find the value of alpha. So all I need to do, transpose to get alpha. Just basic algebra. So this would be, okay, let me not write it like that. If I bring this, if I add 2 tan alpha to both sides, I'll end up with 5 tan alpha, and then if I minus 1 from both sides, I'll get 5 tan alpha is equal to 5. Divide both sides by 5 to end up with tan alpha is equal to 1. Tan inverse of 1 is going to give you 45, or instead of saying 45 degrees, because it didn't specify if you wanted to, pi on 4 radians. That's the C. Remember, the tiny c means circular measure, right? We use that to represent radians. Okay, so how's that? You understand what I did there? Yes, no.
Yes, ma'am.
Who just answered?
No, Stefan.
Who?
Kebwan, your star student.
Oh.
I understand as well, miss.
Okay, nice. All I did, that was just transposing, right? Basic algebra. But if you need me to explain any step, just let me know. Can I clear this off now?
Yeah, you can go ahead.
Okay, clearing. Okay, so do part B for me, please. Part B. But did anybody finish part B? Yeah? If not,
No, yeah, miss, my bad.
that's fine. Okay. Okay, yeah, after. Right. So, yeah. This squared, this tells me that most likely I'm going to end up with a quadratic, right? I am going to end up with a quadratic. So if I put that, if I rearrange this, I'll get 2 sine squared. So let me just put it like this. So remember, sine squared theta is the same as saying sine theta squared, right? Plus 3 sine theta. Let me just put this in brackets for you to see. And then plus 2 is equal to 0. So this right here is a quadratic. Why? Because remember, a quadratic is uniform ax squared plus bx plus c. So this is a quadratic, right? It's in the quadratic form. So how do we solve a quadratic? Well, we have 3 ways, right? The formula, factorizing, completing the square. But it's common to, you know, do factorization, like attempt to factorize the quadratic first. Or remember, not all quadratics can factorize, right? But usually your first option is to factorize. Then you might go to either one of the other methods, right? So we're going to factorize it. So some people prefer, you know, just to factorize just like this, right? But it may help you if you use like a substitution. So what exactly do I mean by that? Well, I see sine theta, right? If I make a statement like let y equals sine theta. So instead of working with this whole thing, I say let y equal sine theta. So what I end up with is 2 minus y squared plus 3y plus 2. So you don't necessarily have to do this in blue, but it might make it easier for you if you could see, you know, just this variable y instead of seeing this trig function here, right? Like I said, not necessary. I just find that it's easier if you make a substitution like this, right? Because now this looks a little less complicated. All you have to do now, factorize, right? When you factorize this quadratic, the factors would be y minus 2 and minus 2y minus 1. Everybody following so far?
Yes, sir.
Yeah, that looks it looks doable.
Miss, my head is hurting me, but I'm fighting for the headache.
I just did the quadratic formula because I have a lot of practice with it and I thought it would be faster that way. For me personally, but obviously either method is valid.
Yeah. Like I said, it's your choice, right? Your choice, whatever method, you should get the same answer. So if I want to solve for y, I would get y is 2 and y is minus a half. Like I said, I use the substitution because it might be easier for you to see it like this instead of seeing something quote unquote complicated like sine theta and whatever. So now that you know y is equal to 2 and y is equal to minus a half, what does that mean? Sine theta is equal to 2 sine theta is equal to minus a half. So these, I'm working with this, I'm working with this, right? Everybody good with that so far?
Yes. Yeah, it looks good.
Yes, Mr. Following.
We're trying to find the value of theta. So like regular math, you know, when I say regular math, I mean math that is not art math, right? If I want to find the value of sine theta, all I would say is sine inverse of 2. But everybody, put sine inverse of 2 into your calculator and tell me what you get.
Well, I don't have a calculator, but I mean, I know offhand that the sine function is bounded by 1 and -1. But everyone else should probably get undefined or error or something like that.
Yeah. So if you do put that into your calculator, sine inverse of 2, you'll get error, right? Why? If you go back to the sine graph, so I'm just taking these, right? And going all the way down. The maximum value of the sine graph is 1. The minimum is -1. It will never go out of this range, right? The highest possible value you could get when you substitute the value of theta into this right here this trig function, if you any value of theta you substitute into this, it will never pass 1 or minus 1. It could be equal to 1, it could be equal to minus 1, but it will never be greater than 1 or less than minus 1, right? Hold on. And that is why this is invalid, because 2 is greater than 1, and therefore it is not in my range, right? So that's why you get an error on your calculator. But this is valid because minus a half is within my range. So theta. If I find sine inverse of minus a half, what would I get? Just put it into your calculator. Anybody?
Miss negative 30.
However, there's a problem. Negative 30. Is this within my range? Yes or no?
No.
No, it's not within my range. So what do we do in this case? The people who are with me, quadrants, let me say SPAC. That. So usually when we're trying to find, when we're doing this, right? Let me just erase, like I did this before. We usually call this acute angle alpha, right? And we take the positive value. Why? When I say acute angle alpha, right, I mean the angle from the x-axis. So this angle here is 30. This angle from the x-axis, this is 30. This is 30. Well, it's technically minus 30, but I'm not worrying about that right now. This acute angle alpha is the angle from the x-axis. So above the x-axis or below the x-axis, the acute angle is 30 degrees. Okay. We said that minus 30 is not in my range. And we also said that we want all possible values of theta within this range. When I substitute it into this expression on the left-hand side, I would get 0. How exactly do we do that? Well, that's where our knowledge of quadrants comes in. If I measure from my positive x-axis going counterclockwise, right? So I did this last class. The angles are measured counterclockwise. Positive angles measured counterclockwise. Negative angles are measured clockwise. So if I measure this angle, let me see. If I measure this angle from the positive x-axis, right? Sine theta, negative. This is a negative value. Sine is negative in the third and fourth quadrant. So if I measure this angle from my positive x-axis, right? And we said we go in counterclockwise. If I go all the way around from the positive x-axis and I stop here, why am I stopping here? Because I see that this value is negative. Sine is negative in the third and fourth quadrant. I measure from the positive x-axis and I go all the way to the third quadrant. The question is, what is this angle here? This big angle from the positive x-axis to this line here? Well, it's 180 plus 30, which is going to give me 210. How did I get that? The angle on a straight line is 180, and then if this angle here is 30, then this entire angle has to be 210. But that's only one possible value of theta. I also said, since sine is negative, that value of theta our value of theta that we're looking for can also be in the fourth quadrant. So if I draw another one from the positive x-axis, measuring counterclockwise all the way around into the fourth quadrant, the angle I am interested in is this big one right here. What angle is that? Well, this whole thing is 180. This is 90. And that has to be. Or if you didn't want to do that, you could have said 360 minus 30, which is 350. Do you understand that? I did this last time.
Yes, miss. I understand.
Wait, who said that, Josh? Was that Josh?
Yes, miss.
Well, you were here last time, so that's great that you understand. But the people who weren't here last time, like last time I was going a lot slower. This time I was going kind of quickly because I did it already. But if there's something that you don't understand, please let me know.
No, I think I get the hang of it.
Okay. Anybody does not understand this? You don't understand how I got 180, 90, 60? Like I said, you didn't have to say that, right? You could have just said, if you know that this whole thing makes an angle of 360, but I'm stopping 30 degrees from that, then 360 minus 30 is 360, right? That's another way of thinking of it. So, can I clear this?
Yeah, you can clear it. We can move on from there.
Yes, miss. You can clear it.
What to do, what to do. Okay, let's do another one. 24. Yep, there we go. Okay, let's see, which one are we doing? Let's do this and this. Yeah, let's do both of these. Wait, this one is kind of, let's do C first, and then we could go back to B. So we're doing C, right? Proven identities. This is one of the first things that we did. Not in this class, like this session, but a while back. Oh wait. I lost a minute. Okay. So rejoin after this, right?
Understood,
Miss.
miss.